All right, so welcome to lesson 7.2 and 7.3. The reason why you're not seeing the textbook up is because we are actually abandoning the textbook for these two sections because, well, you guys have already learned all of this, and we do have quite a bit to get through, and so I thought it would be better for us to go off script a little bit. It would be more effective in this case. So there are two worksheets that I handed out. The first one is the main notes, which says lessons 7.2-7.3 at the top. And here we have some examples from class. And actually, the first thing I'm going to do here is I'm going to just kind of separate this. So we're going to talk about a few different things. These are going to be like your normal stuff on the left, and we're going to have special cases on the right. So I'm just going to put special cases. Okay. And we also have this worksheet where I kind of just made problems where they demonstrate exactly or the methods that I want to go through, and especially in a particular order. Okay, it's one page. There are the answers on the back, but obviously the answers don't help you if you don't know the process for getting those answers, which is what we're going to go through now. All right, so first of all, this is all about factoring quadratic equations, and there are a lot of different methods for factoring quadratic equations, and number one, though, is I just want to talk about why we factor them. So I'm just going to put number one here, and I'm just going to actually put a little line going across here, because this is probably the most important piece of this of all of factoring actually. If I said a times b is equal to 0, what could you tell me about a or b? Well, you would say, well, if a was like 100, for example, what would b have to be? Well, it would have to be 0. And if b was 99, what would a have to be? A would have to be 0. So we would say that either a is equal to 0 or b is equal to 0. Or both of them could be 0, right? And by the way, if you're familiar with logic, when you say an or, that is the case here as well. When you say a is equal to 0 or b is equal to 0, you're saying that, well, either a could be 0, or b could be 0, or both could be 0, okay? This is basically the foundation of why we factor, because we are interested in basically where these cross the x-axis, which is where y is equal to 0, which is why we set this equal to 0. And pretty much with all of factoring, you're going to, at least for polynomials, you are going to go from one state to another state. And what state do you start with? Well, you start with something like this. I don't know, let me just put something up here. X squared plus 3x minus 1 is equal to 0. So you start with this state where you have terms. These are called terms, and they're separated by addition and subtraction. And the state that we want to get to is things that are multiplied by each other equals 0, like a times b is equal to 0. And it could be, this could be like a factor, like, I don't know, x minus 1, x plus 2, whatever. Doesn't matter what's in here. The important thing is that these are multiplied by each other, and they're equal to 0, because then we can separate them where the first one is equal to 0 and the second one is equal to 0. And you could have a bunch of things, 1, 2, 3, 4, 5 things, all equal to 0, and you would set each one of these individually equal to 0. Okay, not x is, like if this was x is equal to 0, or if this was x plus 3 is equal to 0, so on and so forth. All right, the state you're going from, this terms separated by addition and subtraction, you want to factor it to get into state where you're multiplying things, so that way we can get further with the math. Kind of similar to in the past we did what was it? Just simplifying some kind of fractions, kind of crazy fractions. You might have like x cubed, y squared, z over x, y, z squared. And we had an issue before where we said, well, if there was like an addition or subtraction in here, all of a sudden this thing is locked. Okay, you can't get into this. All right, you couldn't just cancel this z, these z's, these y's, and these x's because it's locked up with this addition and subtraction. But if you get it to the point where you just have a bunch of things multiplied by each other, even if they're complicated, for example, you might have an x minus 3 down here, it's still just another thing that's multiplied by the rest, then all of a sudden you can go ahead and you can start canceling these things out. So in a sense, for when you're simplifying fractions, you want a bunch of stuff multiplied on the top times a bunch of stuff multiplied on the bottom, and that unlocks it, so to speak, where you can start canceling these things out. But the moment there's an addition or subtraction anywhere in here, minus 1, whatever, all of a sudden it is locked. All right, so again, same thing is true for your factoring, going from one state to the multiplication state. All right, and that's why this whole number 1 is super important. That's why we said a times b is equal to 0. Then we know that a must be equal to 0 or b must be equal to 0 or both. Okay, so that's what we're going for here. So let's get to the factoring. So the number 1 major thing you're going to be looking for all the time when you're factoring is the GCF, or the greatest common factor. So if we go to our factoring worksheet here, there are 2 problems, number 1 and number 2, where we're just basically just going to pull out a GCF. So in this first one, we can pull out a K out front. And what's left on the inside is 7K, because I pulled out a K from here. So that's the same as dividing by a K, right? Same thing over here. So 7K plus 9. Okay? And I've talked about this before, but when we pull out a greatest common factor, it is the opposite of distribution. We just pulled that K out of each one of these terms. All right, which is the opposite of distribution. If you want to check your work, you would distribute the K back in, and you should end up back to the original expression. Okay, so let's go on to the next one. So this number 2, we can pull out a 3n, and we're left with 5n plus 2 when I pull out 3n. All right, and pretty much all throughout factoring, like I said, you're going to be looking for GCFs. All right, so that brings us to our next really big factoring method here, and it's factoring by grouping. So factoring, or factor by grouping. And in order for this to happen, you need to have 4 terms. Or at least these are the simplified versions that we're going to do in this class. You need to have 4 terms. Something... I don't know, I guess I'll just use an example. Actually, I want to be arbitrary about it. So you have something plus another thing, plus another thing, plus another thing. And what you're going to do is you are going to group these. Take the first couple and put some parentheses around it. Take the second couple and put some parentheses around it. And then you're going to try to pull out a GCF out of each of those parentheses. And you'll notice that if it is indeed factorable, something really nice happens. So let's go to some examples here. So for number 3, you have this term plus this term minus this term minus this term. So I'm going to end up taking these 2 and these 2, and it doesn't actually matter, by the way, how you do it. It should work out any way, but we usually just take the first 2 and the second 2. Anyway, so what I have here is I have 16a cubed plus 24a squared. Now with this minus, I typically tell students to change this to a plus minus. So I have plus negative 10a. And I know we're going to pull this negative out anyways, but some students struggle with what it means to pull out that negative. So plus negative 10a minus 15. All right, so what I'm going to do is, now that I've grouped these, is I'm going to pull out a GCF. So this first one I can pull out looks like 8a squared. And what am I left with inside? I'm left with 2a plus 3. And for this next one, so if there's a negative in here, always pull out the negative if you can. In this case, I'm going to pull out a negative 5. And when I say if there's a negative in there, I mean in this first term. If this first term is negative, pull out the negative. Okay? So I'm going to pull out a negative 5. And that becomes 2a plus 3. Okay. Now this is exactly what we want. The reason I say that is because I have this thing multiplied by this thing minus this thing multiplied by this thing. It's pretty similar to having, and let me just say that 2a plus 3 and 2a plus 3, these are things that they have in common, right? It would be kind of like saying you have x times y minus z times y. Well, what do these have in common? They have y in common. So we would pull out a y, right? Pull out a y up front, and you'd end up with y times x minus z. Well, we're going to do the exact same thing, except we're going to pull out this whole chunk, this 2a plus 3. Let me undo all that. Okay. And again, I want to be clear. You have this item minus this item, and this is 8a squared times this times 2a plus 3, and then 5 times 2a plus 3. So I'm going to pull out the 2a plus 3. Actually, let me do this so it's more explicit in the notes. So I'm going to pull out the 2a plus 3 out front as a GCF. And what am I left with? Well, I'm left with 8a squared minus 5. 8a squared over here minus 5. Okay, and there you go. There's your factors. Two things now multiplied by each other. Okay. And by the way, if you can always check your work on all factoring problems by just simply multiplying everything back out again, which would be double distribution. Some of you guys call it FOIL, but it's double distribution. And you should end up back with where you started. Anyway, okay, so let's go ahead with the next one, and we'll do factor by grouping. We'll do this one a lot quicker. So in this case, I'm going to change this to a plus negative, and I'm going to put my parentheses around here. All right, and I'm going to go ahead and pull out a 2b squared. So that leaves you with 4b minus 1 on the inside. Here I'm going to pull out a negative 7. And that leaves me with 4b minus 1 on the inside as well. And notice I have these two things subtracted by each other. And you have this multiplied, 2b squared multiplied by 4b minus 1 minus 7 times 4b minus 1. They have 4b minus 1 in common, so we'll pull that out. 4b minus 1. And 4b minus 1. And what am I left with on the inside? Well, 2b squared minus 7. Okay, and there we go. There are our factors. This is super important, factor by grouping. Whenever you have 4 terms, you're going to factor by grouping. And the reason why it's super important, because it might not seem like you have 4 terms a lot, but actually we do a lot of trinomials, polynomials with 3 terms. We factor these very, very often. And this might seem different than the 4 terms, but actually the way that we factor this is we always separate the middle with some kind of equivalency. Like, for example, negative 7x could be separated into like negative 2x minus 5x. If I combine these, negative 2x minus 5x, you get back to 7x. Now, I don't know necessarily what these should be. That's the whole art of, of factoring and utilizing all of these different methods. But all of these end up becoming 4 terms. So when I separated this negative 7x, you'd still have the x squared on the outside, and you'd have the plus 12 on the other side. It's just that we separated that middle term. Okay, and in order to show that, I'm actually going to skip 5 and 6 and come back to those in a second. And we're going to start with 7 and 8. But let's go to the notes first, and I'm just going to put number 4 down here. And I just want to reiterate, so if we have a trinomial, all right, something like this, something, I don't know, let's, actually, let me give this a name first. I call this, or I shouldn't say I call it, it is called the X method, and you'll see why in a second here. But anyway, if you have a trinomial, something plus something else, actually, let me do a different color, something plus something else, and then plus another term, so 3 terms, trinomial. What we're going to do is we're going to break up this middle term and turn it into a polynomial with 4 terms. So we can then factor by grouping. So this is called, this is for trinomials. Okay. And this is our last main method here. Actually, I shouldn't say that. Technically, there's another one that we should cover. That's the quadratic formula. Quadratic formula. I'll just put it here so I don't forget it. Anyways, so let's go ahead and do these trinomials. So, and let's learn about what this x method is. And I'm going to show you starting with 7 and 8, and for a very specific reason, and that's because this 5 and 6 in front of the n squared and x squared, it doesn't have a number in front of there. Well, technically it's a 1 in front, which means that you can kind of use a shortcut for those. But I want to show you the whole method without the shortcut, and then show you why the shortcut works, so that way you don't end up using the shortcut on like something like this where you have a 3 or 7 out front, something other than a 1, because then it's not going to work. Okay, so let's talk about the x method. So the first thing you need to know is that the standard form of any of these, any quadratic equation is ax squared plus bx. Actually, let's do this over here. See where we have some room. Let me zoom in, and we're going to kind of move over here. All right, so we have ax squared plus bx plus c is equal to 0. And when we use the x method, you make an x, like so. That's why it's called the x method. And what you're looking for is, well, first you need to multiply the first and the second term. And in particular, this will be a times c. All right, and in the middle, or I'm sorry, the top, you have just the middle term, which is b. Okay, and what you're looking for, the reason why I put multiplication and addition on the top, is you're looking for two different numbers that will multiply to get you to a times c, and add to get you to b. Okay. The reason why I put some extra room on here is because I actually take, the way I teach is I say the whole terms. So it's a times c x squared, and because when you multiply ax squared times c, it's a times c times x squared. And b, it's b times x. All right, and what's going to happen here is you need to come up with a number, which is this x, and another number next to an x, that will multiply to get to ac squared. When you multiply, say, for example, 1x times 1x, you'll get 1x squared, right? And add to get to b of x. Again, for example, if you have 1x and 1x, well, 1x plus 1x would be 2x. All right, so that's exactly what we want, and that will tell you how we split up this middle term, b of x. Okay, so let's go through and practice that, see how that works. All right, so let's create our x here. All right, and if I take the first term times the last term, that's 3x squared times 8, which is 24x squared. And I always put the times there to remind myself. And then the middle term is just 10x. And that's the addition to remind myself again. And so what I'm looking for, and again, concern yourself with the numbers when you're thinking about the numbers. I'll put in the x's later. But what two numbers multiply to get to 24 and add to get to 10? Well, that's 6 times 4. And more specifically, I'm breaking up a 10x. All right, so that's going to be 6x and 4x. And again, the reason why I put the x's in here, 6x times 4x is 24x squared. 6x plus 4x is 10x. So we are going to split this 10x into 6x plus 4x. Okay, so that will be 3x squared plus, and instead of the 10, we have 6x plus 4x, and then plus 8. Okay, and you see that if we recombine these, it would get you back to the 10x, but that's not the point, right? The point is to get 4 terms here, 1, 2, 3, 4, and now we can factor by grouping. All right, so let's go ahead and factor by grouping then. So I am going to pull out a 3x in front, so that leaves me with x plus 2. I'm I'm going to plot a 4 on the back side here. So 4, and that leaves me with x plus 2. And lo and behold, I have an x plus 2 and an x plus 2. We will pull that out front as our GCF, and we're left with on the inside 3x plus 4. And there you go, factored. All right, let's go to the next one. And again, we'll do the x method here. So draw a big X. All right, 7n squared times negative 8 would be negative 56n squared, and negative 10n in the middle. Here's my multiplication, here's my addition. And so what two numbers will multiply to get to negative 56 and add to 10, it should be negative 14n and positive 4n. Negative 14 times 4 is negative 56, and negative 14 plus 4 would be negative 10. All right, so that's how we're going to split up our negative 10 here. So that would be, that gives us 7n squared minus 14n. And by the way, it doesn't actually matter. If you put the 4n in front and then the negative 14n in back, it doesn't matter. It still works, and you can try that, and it'll work. But anyway, so I have negative 14n plus 4n, and then minus 8. I'm going to factor by grouping. So I'm going to plot a 7n, and that will leaves me with n minus 2. And I'm going to pull out a positive 4, and that leaves me with n minus 2. And I'm going to pull out these n minus 2's. So that's my greatest common factor. I'm left with 7n plus 4. So the factors are n minus 2 and 7n plus 4. Okay, so with that being said, that's 7 and 8. Let's go back up, and I want to show you 5 and 6, and I want to show you a shortcut. But in order to show you the shortcut, I'm going to show you the whole thing first. So let's do our normal x method, and so this would be 1x squared times 12, which would be 12x squared. And that's my multiplication, and I have negative 7x. That's my addition. And let's see here. So that would be negative 3 and positive 4. I'm sorry, negative 3 and negative 4. X for each of these. Okay. Multiply to get to negative 12x squared. Add to get to negative 7x. So now I can separate these. So I can say this is x squared minus 3x minus 4x. And then plus 12. Now we'll factor by grouping, pull out an x, yep, just an x. So I have x minus 3, pull out a negative 4, and I'm left with x minus 3. And then I've got these two greatest common factor, or one greatest common factor of x minus 3, and I'm left with x minus 3 times x minus 4. Now, this guy right here, I could have stopped right after I found, actually, let me, whoops, here's my solution. Let me change my color here. So I could have stopped right here. I didn't actually have to go through this whole process of grouping. All right, and that is because there is a 1 in front of the x squared. All right, or nothing. All right, there's technically nothing in front of there. But whenever you have nothing in front of the x squared, or it's just a 1, right? Then when you do the x method, once you find the two numbers, this was negative 3 and negative 4, and I want you to notice that these correspond with x minus 4 and x minus 3. So you could have stopped at that point, and that will work every single time as long as a, which is right the coefficient of the x squared, as long as a is equal to 1. So if a is equal to 1. If it's not equal to 1, you have to do the entire process like down here. Okay, you have to do the factor by grouping. Because notice, we came up with 6 and 4, and the final answer was not x plus 6 times x plus 4. Right? It was something totally different. And that's all because this a was equal to 3. It was something other than 1. Okay? So let's do number 6, and we'll do it the quick way. In this case, we're just looking for two numbers. And a lot of times I shorten this instead of writing like n. This would be n squared times negative 30, so negative 30 n squared. if this is 1, then I just kind of just put the negative 30 in there because I know I'm going to stop. And this is positive 7. So this is multiplication, this is addition. So the two numbers are, let's see here, positive 10 and negative 3 would multiply to negative 30 and add to 7. So I can go straight to my answer, which is x plus 10 times x minus 3. Bam, done. Pretty easy, right? But again, don't get stuck on using that shortcut because all of a sudden they're going to have these coefficients in the front, like this 7 and this 3 over here, and you're going to get them wrong. Okay. Again, to prove that again, number 8, what did we find? We found negative 14 and 4, and that was definitely not the final answer, n minus 14, n plus 4. Totally different. Okay, so yeah. All right, so let's go back here, and so these are all the normal ways on the left-hand side of, or I guess all the important methods that will work all the time. Specifically, if you don't have to use any of these methods, technically, you could use the quadratic formula literally every single time if you wanted to. It will always solve a quadratic equation, and the quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so you can always use the quadratic formula. All right, now let's talk about some special cases for factoring. The first big one here is the difference of squares. So I'm just going to put number 5 here, and we're going to say difference of squares. And so what do I mean by a difference of squares? Well, if you have some kind of perfect square minus, which is where the difference comes in, it has to be the difference. It's not the addition of squares. It is the difference of perfect squares. So if I have a perfect square minus a perfect square, then this is always going to be factored to whatever the square root of that is, which is in this case is just a minus b times a plus b. That's it. Okay, so let's go to our I got two problems here. So a lot of times I'll rewrite these as a squared minus b squared. So what do I mean by that? Well, 4 could be rewritten as 2 squared. So 2 would be your a. All right, minus, well, how could I rewrite 9n squared? Well, that's the same thing as 3n squared. And this would be your b. Okay? And now I have a difference of squares. So this is equal to, this becomes 2 minus 3n, which is a minus b, and times 2 plus 3n. There we go, all done. Obviously, you don't have to rewrite all these under easy circumstances, but since I'm teaching, I will rewrite them for you. So anyway, so this one here becomes, if I rewrite this, this would be 4b squared minus 3 squared. So this becomes 4b minus 3 times 4b plus 3. And there you go. All right, next one up is the perfect square trinomials, and I really don't use this at all. I don't like it because there's a lot to remember, and I don't think it's very useful. You can always solve these by, just by factor by grouping. All right, just do your normal trinomial x method. All right, so I don't use this. I am going to show it to you, but honestly, I think it's probably not worth the brain power to, to try to figure this out. By the way, this can also, 9 and 10, even though this is a difference of squares, if you don't recognize this, there are a couple of other ways to solve this thing too. For example, if I rewrote this, number 10, as a trinomial, I could definitely do that. This is the same thing as 16b squared, and you might say, well, there's no b, there's no middle term. Well, hang on a second, that doesn't look like a b, does it? 16b squared, well, technically there is. You could say plus 0 times b. Isn't that the middle term, 0 times b? and then minus 9. Okay, and then you could, go ahead and do the x method. It should work identical. Okay, so you can always rely on that x method. All right. Anyway, so let's go over the perfect square trinomials. So I'm going to come over to the notes, and I will say perfect square trinomials. And I'm going to put a square there. That's what that means. Perfect square trinomials, because I don't have a lot of room. Probably could have fit it in there, but that's okay. All right. So what do I mean by perfect square trinomial? Let me show you the examples, okay? Number 11 and 12 are considered perfect square trinomials. And that's because first you're going to identify the first and last term as perfect squares. X squared and positive 1, those are perfect squares. Just like this one right here. 16v squared that's a perfect square. 4v times 4v and 9. All right, but that's not enough. You also have to test the inside here, because this would be the same thing as x squared. This would be, in this case, it's technically negative 1 squared, because this is a negative. And again, you're going to see this is kind of complicated. This is why I don't really like it. But anyway, this inside piece should be 2 times a times b, which in this case would be 2 times a is x times b is negative 1, which is equal to negative 2x. All right, and that works. That means it is a perfect square trinomial. The first and last terms are perfect squares, and the middle is 2 times a times b. Same thing with this one. This could be written as 4v squared. This would be 3 squared. And why it's positive 3 is because this here is positive. That's why. Over here, this was a negative 1 because this sign was negative. Just another thing to remember, right, for this method. But anyway, 24v, well, is that equal to 2 times a times b? Well, 2 times 4v times 3 is equal to 2 times 4 is 8 times 3 is 24, 24v. So yes, this passes the test. We have just determined that both of these are perfect square trinomials. So let me just write that formally for you on your notes. Oops, lost that there. And again, I just can't reiterate. I don't even use this one as a teacher. It's just I don't think it's worth memorizing. I didn't show you the answer to this yet, but I'll show it to you now. So if you have something like this, a squared in the formula that we just said, minus 2 times a times b, 2 times a times b, plus b squared. All right, if it's a minus, then your factors are a minus b times a minus b, okay? Which is, by the way, the same thing as saying a minus b squared, okay? If you have a squared, perfect square, plus 2 times a times b, plus your b squared, then that is equal to, you guessed it, a plus b times a plus b, which is equal to a plus b squared. Those are the factors. Okay. All right. So let's go ahead and actually do these then, get them out of the way. It is one of our special cases. But anyway, so in this case, like I said, we would have this would be x squared minus 2 times x. I'm sorry, it's actually plus 2 times x times negative 1. All right, which is why that negative comes out here. Plus negative 1 squared. If you were to expand this whole thing out. So this first one, x is a and b is negative 1, which means that this is a, whoops, not a is x. X minus 1 squared. And there you go. There's your factors. And this one here would be 4v squared. And again, I'll write it out, I guess. Plus 2 times a, which is 4v, times b, which in this case is 3, plus b squared, which is 3 squared. So this becomes 4v minus, plus 3 squared. Those are the two factors. All right. Again, I wouldn't even do it like this. I mean, unless it's something super obvious, I just use the X method. So anyway, all right. So let's move on here and go to number 7, which is very important, and it's a huge pain in the butt. And this one is the sum or difference of cubes. And unfortunately, this one you got to know. I'll put a little star next to this one. This one you got to know, and there's just no... I really hate memorizing formulas, kind of like the quadratic formula. But in this case, there's just no other way. You have to memorize it. So if you have let's do the sum of cubes first. So by the way, we only had difference of squares. Okay, only have a difference. There's no such thing as a sum of squares. But for cubes, there is a sum and a difference of cubes. So let's do the sum first. So here we have, if you happen to have a perfect cube plus another perfect cube, so a cubed plus b cubed, then you can factor this by following this formula. It would be a plus b times, and that's a squared. And this is the opposite sign. So this is all plus. So now this is the opposite sign, minus a times b. And then it's always plus b squared in the end. Always plus b squared. So I guess the big thing is you start with the same sign and then you use the opposite sign, and there's always a plus at the end. Okay, that's the pattern. So if we have a difference of cubes here, a cubed minus b cubed, then that would be equal to, follow the pattern, a minus b, a squared, change the sign to plus, all right, plus ab, and then always plus b squared. Okay, so it's the sum or difference of cubes, and again, there's just no way around it. You're just going to have to remember that one. So let's go ahead. Once you know it, it's easy in practice. So like, let's do number 13 real quick. So this is x cubed, and 216 is the same thing as 6 cubed. So this is a difference of squares. So the factors of this are, let's go through it, x minus 6 times x squared. In this case, it's plus, I got to flip the sign, plus a times b, or x times 6, which is 6x. And then always plus b squared, which in this case would be 36. Okay, and then the last one here, 464, that is 4 cubed. So this could be rewritten as 4a cubed plus 1 cubed. 1 is also a perfect cube. And so this is a sum of cubes. And so this becomes 4a plus 1. And then you got to square 4a, so that would be 16a squared, and then opposite sign, and then a times b, which is just 4a times 1, so 4a, plus b squared, which is 1 squared, which is just 1. Okay. There was one other method that I did not cover at all, and that has to do with solving. So let me just, it's not really a method, it's just solving algebraically. So let me just do this in a separate color, I guess, and I can't remember the actual name of this, but we'll put it in here. This is solving a square, so so say, for example, I'm just going to make up an example here. Say, for example, you had something like, I don't know, like, let's say 3x squared. Actually, let me move this down here. So say, for example, you had 3x squared minus 1 is equal to 0. All right, you're just trying to solve this thing. All right. Well, this is not a difference of squares because you have this 3 here, right? So how do you solve, or how do you solve for x? Well, just solve algebraically, right? So it's gonna look like this. So isolate the x. So here I've got 3x, and I'm gonna add the 1 to the other side. So plus 3x is equal to 1. I'm sorry, 3x squared is equal to 1. Then I'm gonna divide the 3 over. So x squared is equal to 1 divided by 3. Now I'm going to take the square roots of both sides. And whenever you take the square root of an x squared, you have to be very careful and say x is equal to plus or minus. So in this case, x is equal to plus or minus square root of 1 over 3. Now this can be simplified. Okay, I'm not going to go through the process of doing that. Normally, we would simplify this. Well, actually, maybe I should show you the process. What the heck, while we're doing it. So let's go ahead and do that. So x is equal to, in this case, this is equal to the square root of 1 over the square root of 3, which is equal to 1 over the square root of 3. And the problem is, I can't have a radical in the denominator, so I'm going to multiply top and bottom by the square root of 3. All right. So what I get on top is 1 times the square root of 3. Don't forget your plus or minus. So 1 times the square root of 3 is just square root of 3. And then square root of 3 times square root of 3, whenever you multiply the square root of something by the square root of itself, you just get 3. Because square root of 3 times square root of 3 is the square root of 9, and then square root of 9 is 3. That's why you get that. Okay? So in this case, here's our example. Okay? Yeah, but that's not the whole point of this. The whole point is, if you have 3x squared minus 1, you can just solve, right? Just isolate the x, okay? So let's see here. All right, I think that's going to be it for the notes. I think I'm going to do a separate video just going through all of these examples. We'll call this the homework, okay? All right.